There are different kinds of orbit for a satellite to circulate around the Earth. At this time, I will show you two kinds of orbit. First, this orbit is called geostationary orbit, which is a circular orbit approximately 36,000 km above the Earth. The satellites follow the direction of the Earth's rotation. As the speed of the satellites and the rotation of the Earth are same, the satellite will stay above the same position of the Earth. In other words, geostationary satellites can't observe the other side of the Earth. You have to have at least two more satellites to cover a whole globe. This is an image taken by Hemawari 8, a geostationary Japanese weather satellite. It looks wide, and the satellite can capture images every 10 minutes. Since Hemawari 8 moves in conjunction with the rotation of the Earth, it stares at the same side of the Earth at any time. As I mentioned before, the spatial resolution of the Hemawari satellite is 500 meters, which is very low compared to other Earth observation satellites, because Hemawari flies far from the Earth. However, by flying 36,000 km away, geostationary satellites can widely observe the same area all the time. Another orbit which I'd like to explain is polar orbit, in which a satellite passes above the North Pole and the South Pole of the Earth. While the satellite circulates around the Earth is rotating. Therefore, the satellite will observe a different area at the second orbit from the first orbit. For example, if a satellite observes Tokyo at the first orbit, it observes Beijing at the second orbit. Satellites with a polar orbit will circulate around the Earth over and over. Then, they will cover a whole globe. Generally, typical polar orbiting satellites conduct observe at the same time around 10 to 11 a.m. when the satellite flies from the North Pole to the South Pole. On the contrary, when the satellite flies from the South Pole to the North Pole, the time of observation is around 10 to 11 p.m. Radar satellites can observe the Earth both during the day and at night, but optical satellites can't observe during the night. They have only one chance of observation for each single orbit. It takes about 100 minutes for a polar orbiting satellite to circulate around the Earth once, which means optical satellites can observe the Earth approximately 15 times a day and 30 times a day for a radar satellite. The altitude of a polar orbiting satellite is flexible, generally between 400 km to 1000 km. It is way lower than the geostationary orbit, which is at 36,000 km. This is the reason why polar orbiting satellites can provide high-resolution data. However, the field of view is very narrow and it takes a lot of time to cover a whole globe. This is image showing the footprint of the MODIS sensor, which is on the Terra satellite developed by NASA. Its spatial resolution is low, 250 meter, 500 meter, or 1000 meter, but its swath width is quite wide, approximately 2,500 km. As the satellite observes the Earth from the North Pole to the South Pole, the entire image looks like many strips or belts. You can see the gaps between each belt. The gaps are bigger in the area of equator and at low latitude, as the Earth is a spherical body. These gaps are filled at the next cycle as observed areas are shifted little by little between each cycle. This is a summary of geostationary orbit and polar orbit. A big difference of altitude brings about differences of spatial resolution and swath width. Total coverage is also different because of the orbit behaviors. An important point is that you have to understand a polar orbiting satellite does not observe the Earth all the time. The chance for observation by a single satellite is limited. So, if you want near all-time data, you should combine the data from multiple satellites.